Okay, so well, I'm Jorge Gallego Madrid from Odin Solutions in Spain, and I came here to talk a little bit about automotive network application in the 5Gas project, and concretely showcasing our use case with our network applications. We are located in Murcia, in Spain. And we have two services in the automotive vertical. One is briefly explain the virtual logo, that it's basically a digital twin of a physical onboard unit located in the car, so we can reduce latency and provide robustness to the communications between the car and the infrastructure or the cloud. And we also have this service called the virtual logo migration, that it permits the migration of these virtual logos through the network, so it can follow the vehicle and reduce latency and improve the performance of the system. Prior to the 5Gas project, we had manual deployments of the services. We didn't have a testing-driven development, so to say. We weren't integrated in, let's say, coupled with the network directly, and we were heavy reliable on the physical infrastructure underlying the deployment. Besides, we didn't have monitoring capabilities of the usage and the operation of the applications. So more into detail, the virtual migration network app, how it works. It's an evolution of these initial virtual logo network applications, and it focus, as I said, is to migrate the virtual logos so they can follow the vehicle physically, let's say. Until now, as I said, we needed insights of the underlying network. I mean, insights, concrete details of the underlying infrastructure that shouldn't be, let's say, visible for an application in another plane. And for example, it relied on the access to the SDN controller of the infrastructure. Well, the initial content, I won't go so much into detail, but it needed the access to the, as I said, to the SDN controller directly to operate and migrate the different virtual logos. With our introduction, as we started to work on 5Gas, we envisioned some benefits from the adoption of the 5Gas platform. The first one, obviously, is the evolution towards a 5G aware network application. We adjusted the development following the 5Gas methodology, and we introduced the test, besides the test methodology, following the CI/CD driven development, we introduced the test to validate the functioning, operation, security, 5G awareness, 5G interaction of the network application. We also automated the deployment thanks to the platform, and it was also very helpful, the support for automotive vertical needs provided by the different test beds of the project. And well, at the end, also our goal is pursue the 5Gas certification. As I said, more concretely, before we didn't have access to this SDN. We were dependent on the access to the SDN controller. We need a specific knowledge of the infrastructure, and we have deployments on a specific equipment. After, let's say, it hasn't ended, but let's say after 5GSP, we developed the interaction with the NEF function of the 5G network, the 5G core, which offers this API to retrieve the network metrics, so we can obtain from the 5G information some metrics, some QoS indicators, and what is important for us, for example, the location of the applications in the context of the 5G infrastructure. So we got the idea of obtaining this LID to trigger the migrations of the virtual logos. We also benefit from the generic OVUs that were deployed and put at disposal of the developers in the project, and also obviously of the real vehicles that could be scheduled to make the tests. Also some tuning of the 5G networks helped us. So we evolved from this dependence of the underlying infrastructure in the form of the interaction directly with the SDN controller towards the monitoring, let's say, of the network through a standardized option, let's say, that is the NF. However, obviously the problem is that there is no real NEF implementation in currently, as far as we know right now, of a 5G solution in the market, both open source or commercial, or let's say more private solutions. So we envision two options, two ways of doing this. The first one is that thanks to the project, to the 5GAS project, puts at our disposal the NEF emulator. So we had like a way of interacting with something that could be the real NEF, but right now it is not the real NEF of the network, but we can recreate this real infrastructure, and in some sense the application can be developed and evolved towards that interaction that potentially can be then used in a real 5G network whenever we have an NEF ready. So as I said, this is to showcase the use case in the project. So we performed two demos. The first one was using this through the CI/CD 5GAS, the 5GAS CI/CD pipeline, using the NEF emulator. So we can draw, let's say, in the NEF emulator a couple of cells and emulate let's say a trip of the car crossing the handover area, changing cell and triggering this migration. And then in the second demo, the logic, the underlying logic in the application was kept the same, but now the cell ID was retrieved instead of this interaction with the NEF emulator. We retrieve it from the 5G modem. This was helpful, and it resulted from a collaboration with the University of Murcia 5G testbed, that is the one that was also offered for the project. This is at the end compatible with a 5G real deployment, and it wasn't not directly with the NF, but at the end the means are there and it can be easily substituted with the real retrieval. We had obviously real-time information, the real immediate integration with the 5G network, and as I said, its functionality ready to get the info from a real NEF when available. So, well, this is the generic the OVUs that were available in the testbed where we hosted our application. Well, as you can see here, this is a simple diagram of the operation. We have well, the components of the network application were the manager and the aggregator that handle the information and the scheduling, management, and so on of the virtual OVUs that represent the digital twins of the different real OVUs that are located on the vehicles. So we have them, let's say, in one side, in one domain, and we want to trigger this migration with the NEF emulator. So we deploy the car connects through to the virtual OVU using the 5G network, and now with the NEF emulator, we emulate this path between these two cells that in some sense were thought to represent the real scenario that we will see later. And when this cell change is detected through the NEF emulator interaction, as we can see in the diagram, the migration is initiated and the virtual OVU is migrated to the second site, so the car can connect directly to them and improve latency and improve the overall performance of the system. And now, that was like the first demo, the proof of concept. And now moving on to the real one. This is the University of Murcia 5G testbed where we did like this real demo. I don't think it can be seen very good, but there are two cells. That's the overall coverage of the University of Murcia campus, and in red you can see the two cells we had. So the same OVUs, running the same software, everything was the same. We put it on the car with all the equipment, and we did the same experiment, but in real life, as we said. And just to emphasize this, same software that was running in the other case. The only change was the line of code, so to say, that retrieved the information from the NEF emulator, but now it was retrieved from the real 5G network. As you can see, the trip of the car, it was from one side to the other, and we had like a handover area that it's marked in blue, where the handover occurs. So again, we have the same diagram, so you can see the virtual OU is assigned to the real OU whenever the car starts and we start the application. The network application realized through the real 5G data that it's been that application is monitoring the cell change, and the vehicle is assigned this new virtual OU that has been instantiated, migrated in a closer location. Here also we have the 5G ASP monitoring platform, where all the information about the computing resources and network resources and 5G network are also available. So we can see how in the first, this is the PCA, the cell where the OBUs are connected, and we can see that a migration occurs. It changed from 501 to 502, so we have moved, and we can see also in the computer resources of the second site how the virtual have been migrated, and the new one, it has been instantiated in the second site with the CPU usage spike. Well, here you have more in detail these two resource usage. And well, our outcome from the 5Gas project and the adoption of the platform at the end is that now we have a 5G aware network aware application. Obviously, still dependent on the release, let's say, of a real NEF and availability. But at the end, the operation is the same. We won't change anything from the application because it's already 5G ready. We adopt this methodology of the 5Gas project. We obtain, to be honest, a faster design, the development, deployment, and evaluation phases. We adopted this 5G ASP CI/CD driven development. So now we have an easier validation of the functioning, operation, and so on. We also automated the deployment in a 5G ready testbed, and we used these automotive vertical benefits or capabilities that are offered in the project. We are working on the 5Gas certification, and we also improve some aspect of the network application thanks to this real-time monitoring that we didn't have before. In a more generic way, regarding the 5G ASP automotive vertical, there are other applications in the project in this vertical, two from Yogoko, the virtual roadside unit at the central ITS station, also from VLV and DriveU SMEs, the vehicle to cloud real-time communication and remote human driving, and finally the vehicle route optimizer from Neobility. All of them have leveraged the 5Gas capabilities to include this 5G awareness and interaction. They have benefit from these automotive capabilities offered in the same way as us, and they have been also tested and validated using some of them using these real vehicles connected to the 5G network in the different testbeds. And well, that was everything from my part.